Today's episode is about lesson 2.5 entitled Normal Distribution, Finding Areas from the Values. Our learning target for today is about, so we got find the proportion of values to the left of a boundary in a normal distribution. Find the proportion of values to the right of a boundary in a normal distribution. And lastly, we're going to have to find the proportion of values between two boundaries in a normal distribution. To start with, let's have a small recap on or recall that the distribution of the ITBS vocabulary scores among all Gary in Jana 7 grades is approximately normal with a mean of 6.84 and a standard deviation of 1.55. So what proportion of these 7th grade have vocabulary scored that are below the 4th grade level? So this will be less than 4, okay? So the proportion or the location of the value is on 4, less than 4, okay? So we're going to have the illustration of that part to less than 4, okay? As you can see, we got these all value. Of course, I hope you know this already, how to get these values from the mean. So we started from the mean, 6.84, then we add the standard deviation, 1.55. So 1.55, 6.84 plus 1.55. Then you got 8.39. And then you add another 1.55 to 8.39 to get this. And then you add another 1.55. Okay? So meaning from the right side, you're going to add 1.55, the standard deviation. So you add one standard deviation on this portion, you add 2 standard deviation from this portion, and then you add 3 standard deviation to this last part. And then if this is odd, you do subtraction on the left side. So we got 6.84 minus 1.55, we got 5.29. And then minus 1.55, we got 3.74. Minus 1.55, we got 2.19. Okay? Then from the given statement that we have been read, so it is less than 4. So we got 4 here from 3.74 up to 5.29. So we locate the 4 here. Okay, so this will be the 4. In the statement, it's less than. So meaning to say, if it is less than, it's going to the left. Once it is greater than to 4, it will be going to the right. Okay, so that is the other thing that you have to be reminded. You have to know if it is less than or greater than. Again, once it is less than, you go to the left side. Once it is greater than, you go to the right side. Okay, next. So we can use the empirical rule to find this area because the boundary value is 4, no? It is not exactly 1, 2, 3 on the standard deviation. So meaning to say we cannot use the formula or the empirical rule. If you still remember the empirical rule, we have 68, 95, 99.7. That is our empirical rule. So this is different from the empirical rule, but still in the normal distribution. What we're going to do now is we're gonna calculate, look into this area, this shaded portion. Okay, so what are the things that we're going to do? First, we need to calculate the z-score. Okay, the formula for the z-score is value minus the mean all over the standard deviation. We got a value already, which is 4. Okay, if you remember, we got a value which is 4, and then the standard deviation is 6.84, and then the mean is 6.84, and then the standard deviation is 1.55. Okay, we're going to plug in all the values here in this formula. Okay, So we simply recall the z-score computation because we're gonna use it to do the location of the area. So we're going to check how much area do we have here from 4 less than 4, no? Less than 4. It will be less than 4. Okay? So as you can see, this is new distribution of standardized value that can model with a normal curve having mean value which is 0. So in this part, the mean value here, if we're going to use the z-score, we're going to use the mean value which is 0 and the standard deviation is 1. So this is on the normal distribution and we call this as standardized. Okay, so we have the standardized and unstandardized. What's the difference between standardized and unstandardized? Standardized, we use the value of the z-score, while unstandardized, we're going to use the rho score. Okay? So we have here the standard normal curve. We have the positive 1, 2, 3 on the right side. You see, from 0, then we got 1, 2, 3, and then negative 1, negative 2, negative 3. So this is on standard deviation. This is a representation of the standardized normal curve. Okay? So the first target, if you still remember, we're going to the left side, no? So we asked to find the proportion of the value to the left of a boundary in a normal distribution. So how do we get that? So we have here the sample problem. So we got the 4, and then this is the shaded area. This is our first example, if you still remember. So we got the mean 6.84 and then the standard deviation 1.55. So we need to calculate this one. How do we calculate that? We need to calculate first the z-score. And then upon the location of the standardized normal distribution, we got 0 to 1, 0 to 3, 1 to 3 to the right, and negative 1, negative 2, negative 3 to the left. Don't forget that this is standardized, this is unstandardized. Obviously, they are the same, no? So, these two is the same. Don't be confused, huh? This one is standardized, this is unstandardized. Meaning to say, we use the rho score here on the left side, and then we use the z-score on the right side. Okay? So, you see, we got negative 1.83. So, the z-score now is here. While on this one, we use 4. Okay? So they are the same. So the area here is the same as the area here. Okay? So don't be confused. And then this pass through, the shaded part, pass through with the 2 standard deviation. No? Almost 2. Okay? Next. So from the given table of standardized normal curve, we can get it from here, no? So, each student will receive the table for standardized normal probability, no? So, be sure that you have the 2 sheets of table with you before going to this portion, okay? So, you should have negative z-score, negative and then positive. In our class, I gave them a table with standardized. Okay. So we got a table. So I gave them a table like this. Okay. So in our table, we got negative 3.6 on the first page. On the second page, we have the positive, no? We already checked it. If you still have that, if you don't have this one yet, you can chat me or text me and then I'll send you the link or a copy of this one, okay? You can email me to drangelbertmorales@gmail.com, okay? So I'm going to put the link there on my website. Okay, so this will be, so we go over to negative 1.8. The first thing to do is you get the 2 digits first, okay? So you look for the 2 digits first, the left side. So these 2 digits, 1.8, negative 1.8. Be sure it's negative, no? Because sometimes it is positive. You got 2 sheets of paper. Be sure it is on the negative side. Okay, negative. So negative 1.8, it's here, negative 1.8. Okay, then we got the 3. So on the 3, instead of 3, we'll be having 0.03. Okay, so I got 0.03. So from negative 1.8, then 0.03. Then after that, you got this one as your value. Okay, so we'll be having 0.03336. Okay, so I got 0.336 or 3.36%. So that is the area that is the shaded area. Okay, so we got 3.4 or 3.36. That's the same, no? So in BFW Pub, you can also use this and plot this data, no? So don't be confused, because in here, that's 0, the mean is 0, and then the standard deviation is 1, no? And then you put negative 1.83 on the value. And be careful, it should be to the left of the value, not to the right. To the left, because this shaded area is to the left, no? It's not to the right. So then you click the calculate area, then you will be having 3.36%. Okay? In applets, it's almost the same, no? So we got that and that. And then this one is in the calculator. I hope you have your calculator with you. If not, it's a problem, no? But here in my class, all of them have this calculator inside the classroom only. But outside, they don't have this one, no? But they can use the applets and Desmos, okay? You can use Desmos or applet to calculate. So from here, from the calculator, what are you going to do is, of course, you need to open your calculator first, and then go to the menu. Just press the menu, okay, menu, and then go to probability, and then go to distribution, okay, distribution, and then do the normal CDF. So from the normal CDF, you will see this one, no? I hope it can be seen here. So you will see this one there, okay, negative 9E99. So that's almost 1,000, no? It's 1,000. And then what you need to do is, on the upper bound, so you will see this one, no? You type, from the upper bound, you type negative 1.83. And then 0, still 0 on the mean, and then standard deviation 1. Okay? So then press OK. Be sure that it will be the same. So the answer will be the same. So we got that 0.033625. Okay? So that will be the answer. Okay? For the calculator. So this is the applets. Okay, I'll show you the applets, no, so that you will be guided as well, no. This is free. Okay, let's go with the applets. So this is a StatsMedic. So you go over here. This is free. Okay, you can use this one for your calculation. So now we'll be on probability. We're done with the one category variable single group, and one quantitative variable single group. We're done with that. So we are now on the normal distribution. So you'll see this one is our value, no? So calculate, and so the SD will be 0, and the mean is 0, and then the SD will be here is 1. Okay, then you click the plot, you will see the plot there. And then you go over to the left side, because we are now on the left boundary, no? So what is the value is negative, what's that? Negative 1.83. Okay, negative 1.83, and then you just click the calculate. Okay, you click that, and then you got the value already, no? Immediately you can get the value out of the applets. And you can also copy the diagram, no? The normal curve. So the area is still 3.36, you see? You simply put the value of the z-score and then you got the area already, no? No need to calculate too far, no? So what you need, this is standardized, okay? So if it is not standardized, unstandardized, the mean will not be 0, no? It will be 6.84. And then this will be 1.55. And of course, this will be different, no? This will be 4. So remember that? So that is the, you see, this is the value, no? 6.84 for the mean. This is the row score. 1.55 for the standard deviation, the row score. And then we got a 4 here. And then if you're going to click that, it's almost the same, 3.35. There's a point of difference, no? This is a margin of error. So approximately the 4 is here. You see, if you're going to click that one, it's not working now. So anyway, this is 4 already. So this is 4. So got 4 there. So this is our standard, unstandardized computation. So that's the difference, no? You see, they are still the same, but the only difference is that we use the row score on the unstandardized, and then we use z-score on standardized. Okay, so again, this will be 0 for standardized, and this will be 1 for the unstandardized, for the standardized, and then this will be negative 1.8, no? Negative 1.83, right? It's negative 1.83. Got that? So still the same. The only difference is the presentation of the data. Now the data is row score, and then the other data is the z-score. Okay, going back to the problem set. Where are we? So we are now on the procedure. So what we did now, this is only a summary on the things that we did, no? Earlier. So we go over, we draw, and then we perform the calculation. Okay, so we do the calculation, the z-score, we check the z-score, and then we check the area. Alright? So then, let's have another example here. So we got many studies on automobile safety suggest that when automobile drivers must make emergency stops, the stopping distance can be modeled by a normal distribution. Suppose that for one model of a car traveling at 60 miles per hour under typical conditions on dry pavement, the distribution of stopping distance is approximately normal with a mean of 165. Okay, so this is the mean. And standard deviation of 4. So that's the SD, the standard deviation. There's a situation here. Martha is driving one of these cars when she spots an accident 170 feet in front of her, okay, and needs to make an emergency stop. Okay, about 1% of cars of this model will be able to make an emergency stop in less than 170 feet. Less than 170 feet, meaning to say the normal curve is going to the left. Okay? So the area will be going to the left in this portion. Okay? Next. So the next step, we draw it. So we get 165, and then we add 4 to the right, 4, subtract 4 to the left. Okay? Then we got 170, because it's less than, so we shade the left portion. If it is greater than 170, we shade the right side. Again, the answer or the given is less than 170, no? So that's why we got here 170, and when we shade this area, that's why it is going to the left, okay? Less than 170. The next step, we calculate it. Okay, we calculate the z-score, and the z-score is 1.25. Now, to get a 1.25, what we do now is we get our table, okay? So, I go to the table, positive 1.25. So, I go to positive 1.2. Okay, from 1.2, it's in the middle. Okay, it's approximately at the middle, okay? So, 1.2, and then look for 0.05. So, 0.05, and then you got 0.8944. Okay, so this is now 0.8944 or 89.44%. Okay, that is on the table. Okay, in applets, we can have that as well, no? So, we can also get 0.8944. Okay, I'll show you how do we come up with the applets, no? Okay, so we're going to the left now. The mean is 165, right? 165. And then the standard deviation is 4. Okay, then what is the value of our 1.25? Right, 1.25. Alright, to the left, still to the left, no? Okay. No, this will be 1. This will be 0, sorry. We can have that, 165. This will be 170. Okay, so this is our unstandardized score, okay? So it is 98.44. See, the same, 98. This is unstandardized, okay? Unstandardized meaning we use the row score, 170, 165, 4. Now, we're going to change this to 0. And this one will be 1. And this one will be 1.25. Okay, so see, it's still the same, no? So even though we change the value, the answer is still the same, 89.44. Okay, but this is standardized because we use the z value, 1.25, and then standardized because you got a mean 0. Again, standardized normal distribution because you got 0 for the mean, 1 for the SD. That is the standardized normal distribution. Okay, now I think we are done with the question there is Martha safe or not safe? No? So the answer is about 89.4% of cars of this model would be able to make an emergency stop within 170 feet. Within 170 feet. So, Martha is within 170 feet. So, is she safe? Yes. She is safe because she is within 170 feet. Okay? But, if it's less than that, then it's a problem, no? There's a problem with that. But you know, this is 89.4%. We still have 10.6% of chances. But it's nice to hear that Martha is safe. That's the most important one, no? That Martha is safe for that, okay? And one more thing, guys. Sometimes we need to calculate, upon calculation, there is a value more than 3.4, 3.6 negative, no? This one, negative 5. This will not be happen, no? This is very minimal to happen, no? Negative 5. So, in this case, we cannot see everything in this because as you can see on the graph, this is too thick, no? This is too thin. We cannot almost see what's going on to that area. That's the limit of the computation, no? So we didn't know if this will occur or not occur because the area of the visibility is almost not seen, no? It's beyond the table. Beyond the table meaning it's not on the table, okay? So we're going to continue our discussion to the right. Next start. We're just discussing to the left. So objective number 1. The next time we'll be having our objective number 2. Okay?